The following is a podcast that I originally recorded at the request of Abner Coimbre for the Handmade Seattle 2023 online track. In this recording, I interview Peter van Hardenberg, who is a researcher at Ink and Switch. In this conversation, we talk a bit about Ink and Switch. We talk about what it means for it to operate as an industrial research laboratory. And we talk a bit about what the lab's large goals and ideas are. We talk a bit about the idea of local first software and how it fits in with the rest of the work the lab does. And then we talk specifically about CRDTs and how the Automerge CRDT created by Ink and Switch works to some degree, and also how it can be used to create these local first pieces of software much more readily. Big thanks to Abner for putting this together and letting me republish it on my stream. And thanks to Peter for having this conversation. I hope you enjoy. I'm really excited about this conversation. I think I really didn't know about Ink and Switch until about last year when you gave the talk at Handmade Seattle. And I might have stumbled upon it a little bit earlier than that just because it was announced or something. But I very quickly got interested in all the stuff you're doing. And so I'd like to start there and get to know Ink and Switch for myself a little bit and for the audience a little bit. And I think as a first starting point to understanding Ink and Switch, I want to understand what it means that it's a research lab, because I don't think that's an experience that I have firsthand, and that probably a lot of people in the handmade haven't had the experience of working inside of a research lab and understanding what that means. I wonder if you could give us an idea of what's behind having a lab instead of just having a company. What works differently at a lab?
So first, thanks for having me. I'm excited to be here. Ink and Switch there are four words that we use. We're an independent industrial research lab. And so we'll start with the research lab, but it helps to have this other context to put it in. When you picture a research lab, you can imagine people with lab coats on, maybe some Erlenmeyer flasks or a high energy particle accelerator, something like that. But we don't have any of those things. Our research lab is some software engineer and researchy minded people with their laptops in various cafes and offices around the world, but working together with a shared vision. And the essence of a research lab is that our output is not products that do business, it's knowledge, right? And so fundamentally, the essence of a research lab is that what our output is knowledge. And often it's something new that's not necessarily always true. Oftentimes, I think there's good information out there that isn't broadly disseminated that you can find by just reading papers or talking to people. But often it's also a net new kind of working on problems we don't think anyone solved before. And so to open the aperture one more notch, we're an industrial research lab. And when I say an industrial research lab, what I mean is that our goal is not to prove things about prime numbers just for the joy of it, or to find the deep truths of the universe, though certainly that both of those things can be enjoyable under the right context and at the right times. But our goal is actually to be connected to industry and to understand what's happening out in the world, and to try and bring industry forward along a path that we think is important or where there's a lot of opportunity. And so we operate somewhere in between the ivory tower of academia, where, you're part of a formal institution like a university, and you can do basic research that might not pay off in your lifetime or in the next 10 lifetimes. And indeed, so much of everything that we have around us comes from that work, right? Prime number theory was a curiosity for hundreds of years. Babbage's analytical engine took a long time to be built, but that didn't mean that it was worthless. Business that we're trying to promote, we're in the research game. And that leads to the fourth word, which is independent. We are not a subsidiary of Microsoft. We're not part of a university. We exist on our own 2 feet, funded by the ongoing support of sponsors in the community who care about our work and who would like us to keep doing that work because they share our belief that it's actually vital to the health of the computing future, and we believe can have a big impact on society writ large.
Okay, so I think the first key point there is that your product is knowledge and not a product, a tool to be used directly necessarily, but it's the output is this knowledge that you're creating. And I think another context that might be familiar to the audience that maybe still sounds similar to that, but I think that there might be a distinction here, and I'm curious if there is. How is working at a research lab the same or different from just being funded for contributing to an open source project? Is that basically what it is, or is there some way
Mm,
that it's
Great.
still a different thing?
Yeah, great question. So our mission is to understand problems. It really helps if you ship working software. In fact, we have this motto sort of derived from one of the early DARPA directors, Bonvillain, who said, "You can write all the papers you want, but if you show somebody a robot climbing up a wall, then they'll believe you." And so we really believe in this sort of attitude that like you really have to build the robot that climbs the wall. You have to show people what you think can work, or else they won't trust that it's possible. But we don't just build things because we want to have them. We're very deeply engaged in trying to understand a specific set of ways that we think the world could be different and trying to make those possible. And when you contribute to an open source project, your sort of success is evaluated in, was this patch accepted by upstream? Are people using the software? We do ship some software. It happens from time to time. It's a byproduct of our work. But the fundamental thing we're looking at is, do we understand better how the world could be different? Are we communicating that to the outside world? Is that message getting out?
Gotcha. Yeah, I think for me, when I've read through the Ink and Switch website, there's a lot of these articles that are, they might be just papers, actually, I guess now that I think about it, that are the output of the research. And sometimes they come with code. Is the paper the main thing, or is it sort of the paper another artifact, just like the software is artifact? Or what is a full set of pieces that make up outputting knowledge that is concrete that people can benefit from when you do this, creating the knowledge thing?
I think it's important to situate this in a context. So let's do that. So the goal of Ink and Switch is to invent a computer that helps people think. Like, really fundamentally, we believe that our computing platforms are becoming increasingly hostile to thinking. That might sound a little bit controversial, so let me unpack it a little bit. Basically, there was this idea very early that computers could be intelligence amplifiers, that they could be the bicycle for the mind. That's the Steve Jobs line. And our mainstream computing platforms do not really reflect those values today, we believe. For example, the priorities of Apple are no longer with graphic designers and educators, they're with sending push notifications and optimizing revenue in the App Store. Microsoft historically had a real connection to developers and business types. But today, if you press the start button on your computer, it pops up news snippets. And the last thing you need when you're trying to do your work is a little pop up about some natural disaster in another country or some political controversy. These kinds of things are really distracting. And so folks like Tristan Harris have written a lot about sort of the attention economy and the kind of problems there. But we take it even further and say, it's not enough that your computer doesn't distract you. We actually want to really deeply understand, how could a computer make you smarter? How could a computer help you think, make better decisions, think more clearly, share your knowledge, collaborate with other people, all those kinds of things from the ground up? And what if you began from that mission and designed a computer from the beginning? Now, the offshoot of that work is a lot of other sub projects. So I think perhaps we'll talk a little bit later about local first software, which is something we're fairly well known for. We've been working on this problem for a long time. We think of that as an ingredient in a bigger program, right? We have other work that's going into areas like programmable ink, which is to say, why is it that we don't have a sketching medium that has the expressiveness and freedom of a pen, but has the computational power of a piece of software? You could imagine something like a hybrid of a sketch pad and HyperCard, or the old Flash authoring environments, but designed not to use a keyboard. Now, that work is further out, I think, than some of the local first stuff we do. But it gives you a sense of the flavor of, we're not afraid to push way out there beyond the current computing stack to ask questions about how the world could be different. One of the other areas we're really interested in is around malleable software, which is to say, why is it that your programs, when you use them, there's these sealed up boxes that you can't change or modify or make your own? In your kitchen, you buy kitchen appliances, you buy tools, knives, peelers, whatever. You can make almost anything of any cuisine in the world. the sort of app equivalent that we have for software is you get a thing that can only make one recipe and it changes when somebody else decides that it can make that new thing. You have very little agency over how your software environment is built. We think a lot of that is actually tied to this sort of fundamental concept of the app, right? The data lives inside the thing, somebody else keeps it up to date. So how can we crack that box open? So these are some of the other areas that we study. And this is the bigger program. So to come back to your initial question, which was, how are we evaluating progress here? Our output is knowledge. One way that we share our progress and try to influence society is by writing these papers. And so we call these academic papers. They're not quite academic papers. Sometimes we publish in peer-reviewed academic contexts, but the audience for that, while deeply invested and very technically skilled, tends to be quite small. But they're not really just the typical Hacker News blog fodder either. We try to be very rigorous. We use very unemotional language. We try to be very diligent in sourcing our claims and using footnotes. So again, much like our lab sits between industry and academia and draws from both, our output in our papers sits between industry and academia, and we try and draw from inspirations on both there too. You'll notice, for example, we publish in HTML with live code running in it. The academic tradition is to publish PDFs. And there's a lot to be said for that, but in terms of durability and longevity. But we think it's important to show with a higher fidelity our ideas than you can do with PDF. So output, yes, the papers are a mechanism. Speaking at conferences, coming on podcasts like this and talking about what we think is important. And also writing papers academically, publishing open source. We have some open source projects like Automerge that have been out there. And actually, quite importantly, members of our team taking the ideas that we develop together and bringing them either into their next job, their next professional context, or else actually taking some of the ideas that we work on and spinning out a whole new company to go and pursue and commercialize those ideas. That's something we believe is a really effective way of changing the world as well.
Okay, so that's some useful context that we just covered there. And if I'm understanding correctly, you're saying that there are these different major themes like local first and malleable software and programmable ink, and they're all themes that can be understood as this main goal of a better computer for thinking with. That is the main mission of all this. And then your output is whatever is serving that. So the papers and the open source software are things you're doing that help influence the industry to go in those sorts of directions. Is that a fair understanding of what your work is trying to be?
Yeah, I think that's about right. I think that's well put.
Okay. So last question about the lab. What sort of people end up working at the lab? If it's academic, do you have a lot of people coming out of academia who join, or is it people coming out of industry who join? How does someone end up working at the lab?
So our original founding group was mostly people who had been part of Heroku, which was a platform as a service company built in the Ruby on Rails era that did application hosting. And a bunch of us got together after leaving that organization and said, okay, what's next? And the idea was like, we want to do another thing together, but we're not quite sure what shape that thing has. And, that sort of led into the starting of the lab. But as the lab gained momentum and we met all these just amazing people through our work, we've definitely brought in vagabonds and weirdos from all over. We've brought in amazing people out of academia who have a background in institutions like University of Washington and Stanford and MIT. But we also have lots of just open source people and entrepreneurs, people who've worked for Y Combinator-backed startups, people who have left a job at a big company at a place like Mozilla and want to do something a little different with their work before they move on to the next company. And just great designers and folks who we find along the way, people who we find out of small towns in Croatia, or there's a great Windows developer we worked with who's based out of somewhere in the Midwest half the time, and the other half of the year who is in Merida in Mexico, because that's where his family is from. We find people all over. And in fact, it's important to me in terms of thinking about the mix of folk that we work with, that we bring in people who do have a broad set of backgrounds, right? We don't want people who are all from startup land or the games industry or academia. But again, we want to create this melting pot where different ideas can influence each other and inspire the next big thing.
That's really cool. So I want to zoom in on one of the themes that the lab focuses on now, just so we can start getting from the philosophical ideas into more specific stuff. So I want to learn a bit more about local first. I think that was a piece of what you were talking about a year ago, either on the talk or just stuff I was encountering online when I first discovered the lab that really interested me. And it goes into some areas that I know that I am not particularly skilled at. There's a lot of like questions about network programming and data sort of collaboration tools, which are things that I think have not been the primary focus of the Handmade network, but that we'd probably like to know more about how you would go about building something like a collaboration tool.
Yeah, great.
And so I guess a good starting point would be, could you tell us what local first means to you?
Yeah. So local first software is software that runs on your computer and lets you collaborate with other people. If you have those two things, it's local first software. No collaboration, I wouldn't call it local first software. Runs on somebody else's computer, it's hardly local first. That's a very simple definition. So, like a good test of whether you have a piece of local first software is, can you just unplug the Wi Fi router and it keeps working? If so, that's a good sign you've got a piece of local first software. And like we all have a bunch of software that is more or less local first in our lives. Apple Notes is a great example of software that, meets these criteria quietly day in and day out. You make a note on your phone, you can get it on your desktop later. It's not a problem. On the other hand, there's a lot of software that's like trying but doesn't do a great job of it. Like Google Docs has an offline mode, but you've got to install a browser extension, and then you have to like manually say before you go offline that you want to use the thing offline. And then if somebody else edited it while you were offline, it might just pop up a dialogue saying, hey, there were too many changes. We're not even going to try and deal with this. Sorry, I threw your
Mm-hmm.
data away.
Mm-hmm.
And so that's like where the sort of illusion breaks down. I guess the other thing I might say is that if somebody else can kill off the software, you don't really have it, right? Like that whole
Mm.
killed by Google website, everything in there, it would be hard to call local first if somebody else can take it away from you. It was never really yours to begin with. We think it's important when you're doing the work of your career as a knowledge worker, whether that's writing a book or building a piece of software. Red Blob Games, Meet Patel, great blogger, educator online. He's been building that collection of educational resources for like many years. I'm going to say 20-ish years. I'm sorry if I have it a little bit wrong, but his site is incredible. And of course, he has to have all the source material living on his computer because he's been doing it for so long that if he'd hosted it on something else, it would have got shut down by now. He was telling me about what a pain it was when Flash finally died, and he had to basically re-platform a lot of his material onto the web. And so he's become very cautious about adopting new kinds of technologies. Because as far as I know, he's going to keep doing this for as long as he's here. So I think when you think about your life's work through that lens, it makes you very choosy about the kinds of tools you use. And a lot of the modern tools that we have today would be, let's just say, risky to select. The other thing I'd say, incidentally as well, is this way of building software, this local first strategy. It's so much easier for you as a developer because you build a thing. And then if it's working, you outsource the complexity of this sort of synchronization and networking and all this other stuff to solving that kind of externally. And then it just works, right? Like I'm
Mm.
building single page apps that just feel like basic kind of web apps with React components in them. And everything's just live out of the box. I don't have to think about it. I don't have to do optimistic concurrency libraries or all those kinds of things. You just get that stuff for free.
I like anything where it feels like you get to win on both sides, where your life gets easier and it works in a more ideal way. And I think it's a little unclear to me how it's going to work out that's easier, but as we get into the details, maybe that'll become clearer. I think you might have answered a little bit of this sort of follow-up that I have in there about reasons why having people take away your software is the reason you would want something local first if it means people can't take away the software that accesses your data that you care about. Is there an origin story or a sort of original inspiration of where the local first idea comes from that you could tell us about, if there's anything beyond what you've already
Yeah.
touched?
I mean, For me, the inception of some of these ideas came from this great app that a bunch of my friends were working on called Rdio. If you were not one of the people who used it, it was basically Spotify, but a little bit different. It had better music sharing things, and I liked the app better. And Rdio was this great app, but when you turned it into offline mode, the features really changed. All of a sudden, it was like you were running this whole other app. You could be listening to a track, then go into offline mode, and you couldn't play the track back. But you cached that. I just listened to it. Why can't I listen to it now? I'm in offline mode. And it was because they basically had, followed the sort of conventional sort of cloud first strategy. They built this mobile app that talked to this API that fetched all the data on demand. And then when they added an offline mode, it used a separate set of APIs. It had a separate set of code path. It was almost like you switched into a whole other app.
Mm.
And I think I was taking Muni in San Francisco on the N, and I kept trying to get online long enough to cache the next song, and it kept dropping out. And I was just like, this just seems so crazy to me. And at the time I was working at Heroku too. So I was building these kinds of apps myself, but I suddenly had this feeling like, why are we doing all this by hand? It struck me as fundamentally misguided that we had this assumption that you were always online, and in our own sort of development, trying to make great user experiences for people, we were building all of these like complex interactions where, oh, okay, if they click the button, you update it locally and you send off the API request. And then when the request comes back, if it was not what you expected, you got to throw an error state and then update the thing. And it's just like, why am I doing all this by hand? This is bizarre. And so I started to have this sort of idea that like, what if we just download the data we need, you work on it locally, and then you edit it locally, and then you send things back to the server. And if you did something you shouldn't have done, the server will throw that bit away or correct it, locally. But you have like state transfer instead of like individual RPC, remote procedure calls.
Mm.
You just synchronize the data between the client and the server. And that kind of led down this rabbit hole where I started thinking, if you do that, if you're going to have to be able to work offline anyway, you just move all the logic for the app into the app. And if there's data that the user's not allowed to have, just don't send it to them. And I started to think, honestly, that's how software used to work. That's how software still works if you're building desktop apps, right? You check out a repository from Git, then you edit things locally, and then you push the changes back. Why don't we have that for anything else?
Mm-hmm.
Why doesn't Spotify work that way? Why doesn't Google Docs work that way? Why don't all my tools work this way where I have the data and then I can use it? And I began to feel that the answer basically boiled down to a few things. One is we taught people a different way. Ruby on Rails, web development, server-side rendering, and we obsessively optimized around this sort of like cloud SaaS model where you put all of your users' data into one big Postgres database, or if you're really unlucky, Cassandra or something like that. And then we fetch it on demand whenever they ask for anything. We do all the processing in these front-end clients, and then we send dumb HTML down over the wire. But of course, that's not enough. So that big monolith gets broken into all these web services, and you need all these different consistency models. So you buy 25 different Amazon 3-letter acronym services. And then you've got to run it on a Kubernetes cluster, and you've got to find the right web framework to do all the optimistic updates. And you buy another service to handle streaming the updates between the front ends and the client. You got to learn GraphQL. Then the GraphQL goes into the Express, and then the Express uses your ORM to get stuff into the database. And you got stuff happening in the database. So you need database migration to all this stuff. It's crazy. Like even the simple 3-tiered web app, like, hey man, I'm just making a to-do app. Why do I need to take a course in distributed systems and stand up 25 servers? And then of course, you've got to pay for it,
Mm-hmm.
right? Back in the day, you could get a floppy disk and that floppy disk had the data on it. There's this idea that software is this informational good, right? That the marginal cost of software is zero, just the development cost. But that's not true anymore, right?
Mm-hmm.
Software now is one of those rides at the mall that little kids go on. You don't put a quarter in and it stops moving.
Mm-hmm.
You got to keep feeding that beast. And if you're going to feed that beast, you got to pay. And if you're going to pay, then you got to get the money from somewhere. And now you got to go raise venture capital, right? Now you got to have an ops team and do DevOps. You got to stay up at night when the pager goes off. All of this stuff is nuts. I just want to have collaboration.
Yeah.
Right? I want to type in the text box and you see it. How hard can that be? Why have we moved everything to the server, added all this complexity? Honestly, I know the answer. Like I helped build it. It seemed like a good idea at the time. Okay, so that's part of it is we
Hmm.
taught people this way and the complexity came on incrementally. And you know what? There are absolutely cases where this is the right solution. But I think the mistake is that I like to use this analogy I borrow from Jonathan Edwards. We were promised the bicycle for the mind, but we've been building aircraft carriers instead. So the aircraft carrier here is like the cloud application. Everybody thinks they're building a multi-tenant SaaS app at Google scale for 1 billion users. And we use the exact same technologies to do that as for the little app that we're building to organize like a soccer team's meetings on the weekend. And you can't build just an app for that. No, you've got to build a startup for that. You got to raise venture capital and build a team and sell it to every soccer team in the world. Why can't we just make it easy to build the software that we need in the moment, right? That's
Hmm.
kind of part of this local first idea. The other thing I'll observe is that if you build software in this local first way, because so much of the logic is in the client, there's so little happening in the server, you don't get woken up in the middle of the night that often. If that sync service goes down, your users can still keep working.
Hmm.
Yeah, it might be annoying that they get out of sync with each other. You got to start it back up again. But there's just so much less structural complexity in the cloud and so much lower operational complexity. The cost of operating a service like that is can be literally orders of magnitude less.
That's all super fascinating. When I first encountered the local first idea, I think the only part of it that I really appreciated was from the perspective of who owns the data, that piece of it. And the idea that this means shifting to a situation where if the server goes down, I'm still able to work on my stuff as a user. And even if the service goes down forever, at least I still have access to my data locally.
Mm.
So that part of it was clear. But a big piece of what you just explained was no, this is a much more complicated way to build apps the way we're doing it. And this local first thing is just architecturally works out better for developers, which is a piece that I want to keep getting closer to understanding because it's definitely not something that was obvious on my first encounter to the idea.
Yeah, and I do want to really flag here that I do not believe in silver bullets. There are trade-offs here. We're going to get into that later, I hope.
Uh huh.
And there are cases where this is the right solution, and there are cases where it's not. And what I believe is that not that this is a one size fits all solution to everybody's problems, but that we have been using a one size fits all solution to very large scale enterprise problems to do everything else. And we need
Hmm.
to like change our mindset around what's possible in software and change how we build software for ourselves and each other.
This might be a rather simple question because it might just tie into the answers you've already given, but I wonder if you could explain a little bit about now that we've looked at more closely the philosophy of what local first means, how does it tie into that bigger mission of making computers better for thinking?
Yeah, I brushed on this earlier when I said that if you're doing your life's work in a tool, if you're building a book that's going to take you 20 years, if you've got an academic career, or if you're just collecting your own life there, right? Your notes, your personal journey, whatever. If you're putting that in a cloud app, you're assuming that thing will still be around in a few years. How many times have you like bookmarked something and you're like, oh, I got to read this blog about that technique? And you go back a year later and you read it and it's there. But you go back a few years later, you find that old link in some note or SMS you sent somebody or whatever, and it's just gone. It's 404, man. That's gone. That sucks. I hate
Hmm.
that. And it's the same, but even worse if you put your data into a cloud tool. Like I really loved Trello. Trello is a great piece of software. I used it a lot. It has a lot of my life from a certain era in it. But the Trello today is like a really different tool and it's going on a really different trajectory from what the piece of software I used back then was. And I don't have the option to go back to the Trello that I used.
Hmm.
And if at some point they decide they don't want to pay to host my old data anymore, and I can't blame them, I'm not paying them a monthly fee, then they're just going to delete it.
Hmm.
And if I'm lucky, I'll get a handful of JSON files and for what good that does me. But probably I'll get nothing. Even Heroku, we had this idea of what we called erosion resistance, right? Which is if you let Heroku run your web apps, then we can handle so like Ubuntu updates and security patch releases of Ruby and this kind of stuff. That'll make your life better. You don't have to worry about that. We'll keep you online. But the reality in the long run was that all those apps that we built on Heroku are just falling off the web now, 5, 10 years later, never to be recovered. You can't archive web apps. So all this stuff is disappearing in this, I call it a digital dark age, right? The dark ages weren't dark because they were bad. They were dark because the records are lost. We don't know what happened then.
Hmm.
The software that we build today will be lost. It is being lost already every day, constantly. And so if you rely on these things in your intellectual life, then when they're gone, you lose that record of time, you lose that capability. So why is this tying into a computer for thought? You've got to have the software around for the long haul if you're going to use it in serious, deep work contexts that take a long time. That's one. Another major issue is just that, when I'm doing this kind of like thought work, I often am in an airplane, in a train, I'm sitting in my backyard. I want tools that are where I am. I don't want to have to go and find Wi-Fi to do what I
Hmm.
do. I also don't want to lose my data because I lost my laptop, right? This is not an anti-cloud position. It's about changing our relationship to the cloud. So I think availability is a big thing. I also think performance is a big thing, or responsiveness would be actually more technically correct, which is to say, I want the software to always feel very speedy and very responsive to me, right? If you are cooking in your kitchen, you want a sharp knife. That's the safest tool. Something that does what
Right.
you expect when you expect, it keeps up with your will and your intent. If you've ever tried to type in a text editor that like responds a few frames late, you'll know how impossible it is to get anything done. And the more expert you are with your tool, the more sensitive you become to these kinds of problems. And so again, when we're building tools for thought, I think this responsiveness property is really important.
Gotcha. So I think we've done a pretty good job of covering some of the motivators for what this local first thing means and why we would want to build it. So the other side to that is what is going to be difficult about building stuff that way. So are there difficulties that sort of explain why it hasn't already taken off, or difficulties that are just wrangling complexity that we don't know how to wrangle well? Are there unsolved theoretical problems? Or where are we at on like how hard this is to do?
There are a few areas where we're doing really well and a few areas where there's more work to do. Many of your listeners by now may have already heard about something called CRDTs. A CRDT is a conflict-free replicated data type. That's the academic term. It's a kind of a difficult term to wrap your head around. We'll talk a little bit about what that means in practical terms later. But that's great academic work that came from folks like Preguisa, Carlos Bacchiaro, Mark Shapiro. And a lot of the work that we've been doing is building on those ideas and trying to make them developer friendly. So some of it is actually there were great ideas in academia that kind of just needed to be implemented and made
Hmm.
available. It turns out building stuff is hard and takes time to do a good job of. We've been working with this amazing research partner, Martin Kleppmann, he's at TU Munich, I believe, today, working on Automerge and its theoretical underpinnings since his JSON CRDT paper from a few years back. And so that's a lot of where sort of our work in CRDTs has come from, and that work's going well. There are other great CRDTs out there. YJS is probably the most popular CRDT. It's used by a lot of people in production, and it's pretty good. And really briefly, a CRDT is like a Git repository on a JSON file. So you can make edits to a data structure, and then you can merge those edits from other people later. And if there's conflicts, you have a way of noticing them and dealing with them in a sane way. And to contrast that with Git, Git operates on text files. So if two people edit the same line, Git just throws up its hands and goes, I don't know what to do. Even if those things could be put together, if it understood the structure of the data, right?
Hmm.
Git doesn't know about that stuff. It just operates on the text of the document. So that's what a CRDT is. And that stuff's good and important. I think the areas where there's still a lot of work, both conceptually and technically to do, is around understanding what does it mean to work in this disconnected way. And so as a software developer in the audience, you'll have an intuitive sense that if you commit a change to your local repository, that doesn't mean anybody else sees it. And when you push it, then there might be a conflict and then you have to deal with that. Git is not, let's say, famously user friendly. I think some of that is self-inflicted, but there are some sort of fundamental problems. If you think about like booking a meeting room at an office, if you do it in a naive local first way, okay, you write down that you're going to book some meeting room, but you're offline. Nobody knows you booked it.
Hmm.
Somebody else books the room. You come online. You both show up. You both think you've got the room. Only one of you gets to have the meeting there, right? I don't know, maybe you team up, people solve problems in the real world actually pretty well.
Mhm.
That's a useful sidebar actually, which is a lot of these theoretical problems. Many of them are not so bad when you cross them with reality because it's actually this stuff happens anyway. Oops, I booked that meeting room. Oh, it glitched. I didn't hit save or whatever. Oh, now we're both here. Let's figure it out.
Mhm.
I use the room next door. Okay, cool. So like these things do get sorted out, but it's not free. And as
Mhm.
a developer, you have to learn a different way of thinking about data. And there are cases where the centralized model makes more sense, right? Like for a meeting room, it probably does make more sense to have one source of truth that everybody connects to. And if you're not connected, you can't book the room, right? That's a much more intuitive relationship. Now, on the other hand, if you're writing like a blog post, that doesn't make so much sense to refuse, right? Like I should be able to edit the blog post. And then when I come online, you'll see my changes. That's fine. That's what
Mhm.
we want. Oh, but what happens if we both edit the introduction? Now we get into tricky stuff. And I think my take is that in the long run, local first software ends up growing a little bit of version control into everything you do, right? You
Mm.
need to notice when two people have done the same kind of things. You need to have ways to communicate that there's a conflict or to look at what's changed. And that's something new, right? Like we've gotten used to as software developers working in the cloud. You know what? The people on the edge there, it's just a cache, it's disposable, they're not real. The server is real, right? But in a world
Mhm.
where actually the edge is real and the server is just like a warehouse that shuttles data around, now you have these new problems to solve. And I think that's the area where there's still work to do. For example, if you leave your company today, they turn off your Google account and then you lose everything you've ever worked on. That's good for the company, kind of sucks for you, but like it's kind of understandable. But like, okay, in a local first world, you could ask the client to delete the data and probably it will, but you don't have as much sort of surety over these things. Now, the flip side, of course, is that in the Google Docs world, if I know that I'm going to get fired from the company, I can just copy and paste all the data out of the Google Docs I want to save. Like we don't really know. But again,
Mm.
it's about where is the control? Where are the walls around things? Who holds the keys? It's different in this environment. And that's going to take some time to shake out what best practices look like and what the expectations are going to be, both socially and technically, around how this stuff works.
Interesting. So when you say what the expectations are gonna be, I can see how on the technical side, there's might be questions of if we're both editing the intro to the blog at the same time, there might need to be some expectation of how the conflict is handled technically that we know we can count on this kind of conflict resolution or conflict detection and surfacing in the software. But then we also need to figure out like when is it going to cause really big problems to deploy something like this, just in terms of it doesn't have the right properties, and when is it something we can make work, but it changes the expectations of who has what at any given time.
Yeah. And I have a pretty simple kind of summary. I'm
Hmm.
paraphrasing Martin Kleppman here when I say this. If the tool is about authoring things, right? If the users are making things, then it's probably a good fit for local first software.
Okay.
If the tool is about managing an external resource like a bank account or a meeting room or something like that, it's probably not a great fit for local first software. There's lots of gray area in between, but I think honestly that covers a lot of cases pretty well.
Interesting. Are there any pieces of this that are hard, that are more user interface things? Are there pieces of this where it's just unclear how to communicate to a user what the software is doing for them? I guess I'm thinking of if I were to hand Git to a non-technical person in my life and say, "This is how you'll keep backups of all of
Oh
your stuff,"
God, no,
that would be a
no,
terrible
no, don't do
interface.
that.
But
And in
but the
fact,
question is, how good are we at building interfaces for version control that a non-programmer would understand?
yeah, so this is an area that we're actively studying and talking to people about. Fun fact, we talked to a lot of journalists not that long ago about this problem, and a number of journalists reported being forced to use Git for various things in their career. And man, you think software developers have a tough time with Git. People who don't have a background in software development or who aren't professionally forced to just suffer until they find their way through the thicket of confusion that is Git, it's torment for them. It's really awful. But what we found in talking to journalists is that they're actually manually implementing version control in all kinds of creative ways because they want these abilities that we take for granted as software developers. A great example is basically every writer we talk to will use Google Docs. on top of whatever they're formally expected to use. So if they have some kind of CMS at their newspaper where they contribute, they don't want to edit in there because their editor might be watching them or the app might eat their data or whatever. So they use a Google Doc, they do their editing in there. And when they're ready to share it, then they paste it in the CMS manually. But that can clobber changes, right? So you get all of this kind of bad old days of like document underscore final underscore draft 3 kind of stuff crossed with like real-time cloud collaboration, and nobody's happy anywhere,
Hmm.
right? Like as a software developer, like it's mind blowing that we don't have what Google Docs has had forever, which is the ability to type in a window and have another person see it, or to like select some text and ask a question or make a suggestion in a comment. That doesn't exist,
Hmm.
right? GitHub PRs are like this incredibly Baroque way of emulating that in another tool in a web browser where you have to run a bunch of, if you ever like sit and think about how weird a GitHub PR is, it's like you got to do a bunch of weird command line commands, then you push a thing, and then you go to a website and you make a thing. And then the code review is all happening over here, but not on the code as you're running it or in your IDE. So then you got to check it out and run it locally, but then you got to go to the other window to put comments. Crazy, man. Compare that to Google Docs. Select text. What about X? The other person says, thumbs up, accept suggestion, done, right? We don't have anything like that. So both sides are looking enviously over the fence at each other. We wrote a piece about some of this stuff. It's called Upwelling. It's on the Ink and Switch website, inkandswitch.com/upwelling, where we talk a bit about the professional writing side. And we also include a prototype experience around how you might solve this problem. We don't think it's the like final answer to that question. But again, we're trying to both demonstrate the problem, but also point towards the possibility of a solution. Actually, we don't have to accept the status quo. Things could be better. We can fix this.
I'm very interested to see if we can make a version control with an interface. I've personally not even fully you explained that it's crazy to deconstruct what a pull request is like. I don't feel like I have fully comprehended what it was the first time through. So I also feel it is crazy, but from a sort of only half having figured out how to dance with the pull requests in the first place.
Oh, Git is just a graph database, right? No, that's a joke. Git is a nightmare. There are examples of people solving this problem in the field that are totally designed for like non-technical everyday users. And actually, we all should be non-technical users. The better these tools work, the less of our brain power goes into managing these things. And the more of our time we can spend working on the actual problems we want to solve instead of screwing around with detached heads and trying to understand how rebase works. Right. So, like, really
Mm.
concretely, think about Facebook Messenger. You send a message, you get a little check. If the other person has seen it, there's a second check. In a group message, you see the little avatar icons that show you what the other people in the conversation have seen. So you can just tell so simply, so intuitively, without ever having it explained to you. You see those little faces move down as people read things, right? I think there are analogs of that kind of experience possible for all kinds of different use cases. It's going to take some work to find them, but we'll know that we're getting close when they seem simple and obvious to everybody.
What exactly is the part that is solved by a CRDT?
So if you think about the traditional sort of web app model, you've got a Postgres database somewhere at the back. There's one of those and everybody talks to it. And then you've got clients out there in the world doing stuff. And so I type in a text box, I hit submit, goes up to the API, goes into the database, clobbers whatever's there. You type in your text box, you hit submit, goes up into the API, it goes and it clobbers my value. We call this last writer wins, right?
Mhm.
And whatever granularity that the developer has implemented for that is what you get. So if it submits a whole form as a single monolith and updates the whole record in the database as a monolith, then you'll clobber all the other updates that are there, right? Whatever you got is what you put back. And that's maybe lazy, but it's like also natural, right? That's how the form submit logic works in the browser out of the box. If you want to do
Mhm.
something else, you've got to write a bunch of client side logic or use some library to figure these things out. It's a nightmare. It's all kinds of tricks of the trade that make it possible to emulate a better system. So the
Mm.
idea behind a CRDT is that instead of doing that, what you have is a copy of the data and you make edits to the copy of the data locally. And those edits that you make we record what you do and we record what you saw when you did it. And then we send those up back to the server or to other clients or however you want to distribute the data. That's a separate conversation. But you just send out the changes rather than the whole document. Because that idea of a change is fundamental to the system, it's not like you have to kind of think about how to add this later or is this change going to be big or small. As long as you do the natural thing, when you make edits, we record the edits and then we share the edits, then somebody else gets the edits, right? And a conflict is when two people change the same thing without having seen each other's work. Let's say we're deciding where to go for lunch. Somebody else said, let's go for pizza. Neither of us want to do that. I want to go for tacos. You want to get pho. I put in tacos. You put in pho. That's a race. It's a conflict when they arrived because we couldn't see each other's value. But if I saw the pizza and then I put in tacos and then you put in tacos and say, no, we're not having tacos. We're going for pho. That's not a conflict. It might be a conflict between you and me personally.
Right.
I might turn up and be like, yo, man, I want to get tacos. And then we'll talk it out. But technically, you have made a decision based on full information and said, I don't care what he thinks. We're going for pho. And so that's not a data conflict. It's just a personal conflict.
Okay. So I think this is the part where it's going to be useful to understand that, and to get there, I'm going to have to slow it down now and take it a little piece at a time. So I think it sounds like all of that, there's something about changes and we're trying to agree on a document. So the CRDT is our document synchronization solution somehow. Right?
I'm going to get specific here. When I talk about CRDTs, I'm going to be using the Automerge CRDT because that's what we work on at Ink and Switch. There are other great CRDTs. This is not like the only possible way to do these things. Like with that caveat, I'm going to say, yes, in the Automerge world, a CRDT is morally equivalent to a JSON file. You've got maps, you've got arrays, you can set fields and values, you can insert stuff in the arrays. That's the universe you play in. And so the way it works is you've got some data structure. I don't know, a to-do list is an array, right? With some objects inside it. It says whether it's done or not. It says what the text of the object is, maybe who made it, maybe when it was made, when it was ticked off as done, those kinds of things. And when you make a new to-do item, you just add a new thing to the array. And when you clear a to-do item, you just delete it from the array. Now, if you send that whole JSON file around, then obviously if you edit it and I edit it, now we have a hard problem. Write some kind of algorithm, guess how to reconcile those. But if I just notice that I can see that you tried to delete something from that array, I'm just going to record that fact, and then I'm going to tell everybody else. So what I'll say is, okay, we're going to call the state of the array at the moment where I did that. We'll call that, we actually use like a Git style hash for that. The document has a certain hash that represents its state at that moment. And then you take an action and then you send it to everybody else. And if somebody else does an action at the same time, say we're both looking at that same state and we both do an action, but we're not connected to each other. As long as those actions don't conflict, we're okay. Maybe I delete something from the to-do list and you add something to the to-do list. In mathematical terms, we call that commutative because it means the result is the same no matter what order you did it in. If we both tried to edit the description of the same to-do item, that's not commutative because one or the other of those is all that can happen. If I edit the to-do item to be get milk and you edit the to-do item to be 2% milk, maybe they mean the same thing to us, but only one of those can really be shown on screen, right? Get milk, 2% milk would be like a weird, bad outcome. You don't want that. You want to have one or the other. So that's what we call a conflict.
So when it's the commutative bit is if they're commutative, then even if you and I haven't synchronized yet, commutative actions would still not be a conflict because it doesn't matter which order we apply them. This is like Git in some ways, in the sense that like in Git, you can check out at the beginning of the day and I can check out at the beginning of the day. And conflicts happen when you and I both edit the same part, but we didn't synchronize in between, right? I didn't get to see your edit before mine got applied. So the conflict there is a similar idea, but you were mentioning earlier that there's a difference, and it's not just the self-inflicted part of Git, but there's something about Git that's a little different, which is I don't think it has this concept of actions in it. Is that right? Is that where there's a big difference?
So the minimum size of a Git commit is basically editing a line of text, right? And so this is like a lie for people who really know Git internals, but it's true for the purposes of this conversation. But when you change something in Git, what you're really doing is replacing one line with another line. You're adding lines, you're removing lines, right? And a
Mm.
conflict in Git is if two people touch the same line. But of course, those things might actually be fine to put together. Let's say the file we're working on is a JSON file or a bunch of headers, right? We both add another include to a header file at the bottom because that's the natural place to put it. That's a conflict because like now we're both trying to write in the same line. And I know you can look at it, you're like, yeah, it's fine, just take both.
Mm.
But Git doesn't have that kind of knowledge about the contents of the file. So because Automerge operates on a tree of data rather than on an array of lines effectively,
Mm.
Automerge can actually tell quite a bit more about what you're trying to do, and it collects information in a way that's instrumented. So another example is that if I remove an array item and then put a new item in its place, that's different from editing the item.
Okay. So let me see if I'm understanding what you're getting at. In Git, if I edit a line of text, if I edit a piece of a line, I just go and change a little one of the tokens in a line of my code, for instance. Git understands that as deleting that line and inserting a new one with different content
Yes.
slightly. And you're saying that Automerge can understand deleting a line, inserting a line, and modifying it as different things.
Yeah. So
Is that
our
right?
APIs actually, we use proxy objects in the JavaScript API, just concretely, so that when you call, splice versus delete, we can tell the difference between those and we record them separately. The Git model, you edit the files and then afterwards you call diff and then try and smash them together. With
Ah,
Automerge, we actually instrument the edits in place. This isn't like rocket science. It's just, we call it conflict avoidance. Because we collect more information about what the developer is doing in the code, we can make more accurate descriptions of the edits that are happening. And then those are more likely to give you the desired behavior when you put them together. So that's kind of like a technique. It's
yeah.
the fundamental ideas both with Git and Automerge are similar there, but Automerge is just better instrumented inside your code so it can give you better results that are more likely to work together. Now, I want to come back to the code example because there was a good one here. Coming back to the no silver bullets thing, let's say you edit one file and I edit another file. We both check in, hey, no conflicts. But I edited the file, which was, say, the class that you're using, and I
Mhm.
renamed all the methods. Now your code doesn't work. There's no conflict, right? In Git's
Right.
mind, Git says, yeah, sure, we smashed the files together, no problem. But now all your tests fail. The project doesn't build anymore.
Mhm.
The same thing's true with text, plain text, JSON files, anything, right? It is totally possible for the conflicts to occur at a layer that is not captured by the program. Merge together the two edits to the intro, but we're making different arguments. Now that doesn't make sense anymore. So you need tools, right? In Git, we have like Git log. We can look at the patch history. We can use Git bisect, find where problems snuck in. And so we have a bunch of tools to help us understand the history of what's happened. And if you're going to allow people to work apart from each other and offline, it's as important to be able to say, what just happened, as it is to be able to like smash the changes together in a way that's reliable. Putting together the changes with a CRDT algorithm, that gives you a consistent result, but the result might be nonsense. So you need to
Right.
give people the ability to look and say like, whoa, 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 this isn't what I expected at all. How did we get here?
Yeah.
And make different decisions. Oh, I see. Alan rewrote the intro. I rewrote the intro at the same time. So now it looks all wonky. I'm just going to throw away my edits. We'll go with Alan's. You need to be able
Yeah.
to do that kind of thing.
Okay. I think I'm getting the picture. I'm trying to pull out what's the important part that makes it work better than Git. And I think we're starting to get to
Mm.
what that is. So obviously there's the interface client. We could say, imagine we fixed all the things about Git that don't have to be busted without changing any of the core algorithms. There would still be this case that I get a text file and I can use whatever text editor I want that doesn't even need to know that Git exists. And you can check out the same text file and use any text editor you want that may or may not know Git exists. And once we're done making edits, it uses the original version of the document and the new version of the document on my side to figure out what changes I made.
That's
And
right.
a key difference is this instrumentation has to happen for a CRDT where
That's right.
my editor can't say I didn't know about Automerge. It has to know about Automerge to participate now.
Yeah. And I mean, that is the most effective way to use Automerge. I got to put it
Mhm.
that way. You can run it as a CLI tool and just diff the stuff yourself, but you get lower fidelity results. You get
Right.
better intention preserving if you collect more data at the edge.
Hmm.
The other thing earlier, I mentioned that I was lying about how Git works, right? Git actually doesn't work on diffs. Git
Okay.
actually checks in whole files. And then when there's a conflict, then it runs diff to compare them. And in fact, you can replace diff with your own copy of diff and use a different algorithm. But practically speaking, this doesn't actually work because you have to install that diff and configure it at the site of every user, and then people will end up with different results. It
Oh.
just, it's like one of those things that like almost works, but then when you start to pull the thread, it's like the fundamental model doesn't really cohere anymore. You can't
Hmm.
really do it. Like I've managed to get it working in like a shell environment just for like testing purposes, but I've never seen anyone use it in real life.
Yeah, because if I set up my fancy diff on my machine for the project I'm on, and we get everyone else onto the same thing, and everyone knows how to set this up, there's still the moment that I go to pull some open source code, I have to figure out how to unconfigure my diff
Yeah,
to
yeah,
get
you
that
can do
right.
it on
Yeah,
a per
yeah,
repository basis, but it's just like a lot of
yeah,
overhead.
yeah.
But
Seems
like
like a lot.
conceptually, you could take, if you had Photoshop documents and you wrote a Photoshop differ that used like COM objects and ran on all this,
Mm,
you could do custom diff algorithms for different kinds of files. As long as you also only ever need to work one file at a time. Git also never has the ability to conflict across two keys at the same time. That I'm getting in the weeds here. My
yeah,
point is generally, yeah, the Git model actually works on whole files and then
yeah,
diffing them later,
yeah,
which is fast, but it loses all that extra intent. And particularly when you have big diffs, it really struggles to give good results. You could imagine a version of Git, though, that worked more like Automerge, right? Where maybe it understood the structure of source code as well so that it could operate on statements. You could imagine that it might know about like renaming of methods and things like that because it parsed the source code. Like you can imagine a good version of Git. But I think part of what makes Git work is this kind of like worse is better mentality that comes out of the Unix community. And what files are pretty good. Our programming languages and our community culture practices kind of work within that framework. It's okay. And we just have low expectations for quality,
yeah.
right? We're like, oh, why should my version control be able to solve this problem with me? This is clearly my fault for not knowing that somebody else is editing this file. I will take it on myself to fix it. It's not necessarily the case, right? Like the tool could work better. It just doesn't.
So I think some of the stuff you're getting in there, there are pieces of how a CRDT works that I want to make sure I'm not assuming wrong.
Sure.
It would be tempting, and like the Greenfield's magic version of this would be to start thinking of a CRDT like a C++ template where I could take any data structure I want and just say, here's the automatic transform that now you have the CRDT version of that. For instance, this idea would be that I don't have to really understand how to implement what a CRDT or what it means. I just spec out a data structure. And if it's a tree or for something, I want a tree of strings or something. And then I'm just plug it into the CRDT system and out pops a CRDT version of a tree of strings. I kind of get the impression that that's not possible, that you kind of have to design, because what you're saying, we have to instrument the edit. So we have to decide what the actions are going to be. And that has to be decided based on what the data structure is somehow. So there's got to be some crafting of the data structure from scratch.
So the cool thing is, in general, yes, that's true. But in the case of web apps in JavaScript, what we did was actually we came out of building React apps in the client. And so we built APIs where that sort of just works. So the way it works in JavaScript land is you have an Automerge CRDT document, you say doc.change, and then it gives you a copy inside that callback you give it. You get a copy of the object that is your state, and you just do whatever you want to it in the normal way. And this is kind of how Redux and these kinds of things already work, right? You have the state object that you're going to pass to the render function in React. And so we're sort of doing the same thing. We get this, you make some changes to it, we record the changes, then we send them over the network. And then they pop back up for you locally to your render function. It renders on screen. If you don't already have a backend and you're not already doing a whole bunch of like API calls already, which most of us are, right? That's if you have an existing application that's tightly coupled to a server, you end up having to redesign around like having local state. But if you have an app that's already using local state anyway, then you've probably got some object that represents the state of your app. And you just stick that in an Automerge document and it works. Not only that, but it works for everybody. You just share the document ID, synchronizes everybody else. Everybody gets live collaboration. It's the first time it started working for me, it felt like magic. And a lot of other people have shared that sentiment over the years with me that they just, it has this very like charismatic moment of like, wow, I can't believe that I was doing it the old way before. That
Mm.
was so complicated. Why don't we just do what, like, why aren't we just doing this? And there are, yeah, reasons we've talked about around like managing change over time and what happens when things merge in ways you don't like and how do you deal with all that. No free lunch. But yeah, it feels like those problems are in many ways much easier to solve than the problems that we have already, to me at least.
So if I understand correctly, Automerge is a CRDT where the data structure is basically a JSON document.
Yeah, roughly. You
Yeah,
usually have a state object in your app already,
right.
stick it in an Automerge document, and anywhere where you're going to mutate it, wrap it in a change call, and it just works. And in fact, the thing that kind of convinced me that this idea had legs was we'd written one app and just for ourselves as like a test app. And then it was like, okay, cool. But it's easy to convince yourself your ideas are good. So the next project we did is we took somebody else's app that we just found online. It was like a pixel art editor. And we just stuck sort of the state object into an Automerge document. And it worked like basically right away. The rest of the project time we had was just trying to figure out how to improve URL sharing and add usernames for who the edits were coming from and all this other kind of stuff. It was shockingly easy to get off the ground. But of course, like with anything, to do a good job took more work.
That's really interesting. So you can take something like a pixel editor. I'd be curious to know just how that maps down. So does it matter if I took let me set up a case that I think would be
Yeah, sure.
problematic, and you can tell me if it is or isn't and how you get around it. So if I've got some pixel art editor
Mhm.
and I want to stick it into a JSON document, if I just take a hex code for each color pixel and jam them all together into a string and call that the state of the image.
I'd use a 2D array, but yeah,
So this is my question. If I stuck that in there as like one element of my I've got image colon, that string is my state,
right.
that would fail
So you're
seems like by
blinding
magic, right?
the algorithm, right? Like the more precisely or the more transparently you model your data, the easier it is for Automerge to help you. So like you could imagine the degenerate case here is you take the whole image, render it to a PNG, and then you encrypt it.
Okay.
Automerge isn't going to do anything for you. It'll be like, yeah, I see that this binary key is in conflict. Whoops. But if you have a 2D array and each element of that array is a pixel, then it's really easy. As you set the pixels, right? You just write the color into each pixel. And if somebody else has edited a different part of the image, then they'll have edited those pixels and yours are edited there and it'll commute. And if you have both editors edit the same pixel, well, you can pop up a little dialogue and be like, do you want this to be black or yellow?
Mm,
Or you could just pick one. What we did in our prototype, and you can find this on our website, inkandswitch.com/pixel pusher. Our prototype, we just picked a color arbitrarily. And then if you didn't, we put a little red frame around pixels where we'd done that. And if you moused over it, you could change what color it was. That was a little clumsy because if you had to change a lot of pixels, it was like quite tedious. But you could
mhm.
imagine rubber banding over a section and scrubbing back and forth between options. Like again, this is the interesting part of the work is like thinking about in your app and in your context and for your users, how do you want to deal with conflict and change? But if
Right.
you want to allow people to work disconnected from each other, which again is something we hear from users all the time is what they want. People don't like this feeling of being in the sort of modern technological panopticon where they're like collaborators and supervisors and so on can just stare over their shoulder at everything they're working on. Then you should be answering these questions anyway. And what we're
Mhm.
doing is forcing the issue by giving you the tools.
Okay, so I think I'm getting a picture of this where in order to start building a CRDT by using Automerge, you just want to you'd wanna understand at what granularity Automerge is exposing actions on the data structure and leverage that for your pixels, and I want to be able to merge changes to a particular pixel without respect to the rest of the image. I have to just understand what granularity in the data structure auto merge will do the CRDT actions on. Is that right? I don't know if I'm asking the question in a way that's
Yeah, no,
perfectly clear, but yeah.
you need to think about what your document is that you're going to collaborate on.
Hmm.
And I guess again, like it's one of these things where I thought this would be hard, but it turns out that part is really easy because the obvious thing is the right thing. If you have a bunch of pixels, put them in an array. Don't do some weird thing where you
Right.
jam them all together in a string. That's like kind of complicated and unnecessary because then you got to parse it out again. If you just do
Yeah.
the natural thing, it'll work. Do you have a title for your picture? Put it in a field called title. It's
Hmm.
fine. If two people edit the title, only one of them will appear. That's fine. It's just the title, right? We also have support for more sophisticated edit on large strings, right? So you can do splice, you can do real-time collaboration, or if you have a number that's like upvotes, we have a counter type. Again, it's like
Okay.
JSON
Okay.
like. We've got a few extra operations you can do. But again, the naive first thing you do will work. It's
Mm.
as you go further, you're going to find that you're like, oh, but I have this like slightly more complex need here. Then there's more tools you can reach for. But like the basic thing will work and it'll just allow you to get working and collaborate right away.
Gotcha. Yeah, another thing you mentioned there, the granularity and string. I think that was the other piece I wanted to look at is if I was going to create a Google Docs like experience
Yeah, sure.
on this, would I have to break my text file or my more rich document into smaller pieces than what I would have done in a plain way just to get the merging working? Or that's where I was thinking about.
Yeah. Ironically, the history of CRDTs is actually almost entirely about text collaboration algorithms for
Mhm.
whatever reason, and not even text collaboration broadly, like really specifically plain text. So if you want to do plain text collaboration with a CRDT, there are lots of options out there, RGA and Woot and all these like fun names for these algorithms. We have one of those implemented in Automerge. It's not exactly the same as any of the published papers out there because it started out as roughly, I think, RGA, and it's grown sort of extra bug fixes and enhancements over the years. But yeah, again, in terms of like instrumenting the data, if you have a text field in like a content editable in your browser and you edit it and then you hit submit, Automerge is just going to see a new string and it's going to replace it. But if you're using a more sophisticated text editor like ProseMirror or CodeMirror or Slate or any one of these things, what actually happens as you type is that it's generating little mini transactions, right? Like insert this character at this point. And all the text editors of any note support this because real-time collaboration is just like baseline expectation of all software today. How do you do it? Well, good luck. Try Automerge. But because they need this stuff, they all have APIs that will generate these little changes that say at position 37, insert character J, positions 42 through 48, delete. And so we have an API in Splice, which you take the output of those strings, and then you call it on the text. And then it just makes those little miniature edits for you instead of replacing the whole thing each time. Now, again, you can replace the whole thing each time. It's a little bit slower, right? It clobbers other people's edits, but it's fine, right? If it's just a title or a description on a to-do item or something, it's probably good enough for your purposes. But if you want that more sophisticated kind of interaction, if you're editing a whole 6,000 word research essay, for example, you probably want to have a more fine-grained kind of edit history.
Yeah. I think that is mostly pretty clear. Like, I think I get the idea that I would have Automerge as an interesting example, but the general story of a CRDT is you take a data structure, you figure out how you want to instrument actions, and then I guess the last piece is you have to figure out how to merge actions from different users. So we talk about the commutativity. Are there any like key sort of shape to that? Is it basically the same shape as a Git branch and merge graph, or what's going on there?
So I'll flag again that this is an Automerge specific answer. There are other approaches that are something called state-based CRDTs and Delta CRDTs and so on and so forth. But I think most of the production CRDTs that are out there today have a similar approach, which is basically whenever a user takes an action, you write down what they did and the commit hash that they did it at. And commit hash is a little bit of just like a shorthand for people who are developers. It's something called a visibility vector, really, which sort of says, I could see this state of the document. But that's exactly what you get from a commit hash. So if in your head you think commit hash, that's as close as you need to get. And so then in Git, what you say is, okay, at this commit hash, I'm going to replace this file with that file. And so if you do like a git log -p and get the patch, it's actually recreating that post hoc. But in the case of CRDTs, what you say is, okay, at this commit hash, I'm going to insert the letter J at position 37. And yeah, technically it's not position 37. It's like after the character whose, character ID is some commit hash at some other sort of signifier. But that's inside baseball technical stuff. Conceptually, though, you're like, yeah, at this point in time, I did this thing. I deleted that key. I set the title to get milk. I put a J after that spot. I deleted that whole paragraph. I added a comment, whatever. And so you collect those and they just stack up just like git commit history. And then you just select when you want to collaborate with somebody else, you're streaming those off all the time. And
Hmm.
they're streaming back to you all of their edits. And you're just taking those and integrating them. And basically what you do is you take that edit, and because it comes in a format that's easy to integrate, right? So the change, I said insert after 37. If I'd inserted some other text, 37 might not be the right spot anymore. And so there's a technique called OT, operational transform, where you take these operations, these little edits, and then you transform them. So you'd be like, oh, position 37 is now at 39. So I'm going to add 2. But that's really hard to implement. And we're
Hmm.
not smart enough to do that. So instead, what we do is when we send the operation, we're like, okay, after character with this character ID, which never changes, insert
Gotcha.
this letter. And so when you receive it, it's much easier to merge because you just go, oh, okay, find that position in the text string, boop, put it in there, good, carry on. And if that range was deleted, inserting it in there has no effect because the thing you're inserting it after isn't around anymore. You get the
Okay.
idea.
Yeah. So if I'm going to run over that again, because I think I follow everything you said,
Please.
but the key idea, it sounds like, is first of all, we're not going to just edit the document totally offline and then save a copy into the repo and only do diffs on merge. We're doing this instrumentation thing.
You get
And
better results from that. I'll
yeah,
say you
yeah,
can do both, but you get
right,
much better results if you do it the
right.
way you're describing. Go on.
And if we're instrumenting it, then the next step is we describe each edit in terms that you're talking about this character position 37, and you're putting out that as coordinate system into a text file that is not going to persist like the meaningful. We could just say 37 is the correct position, and my intention was to insert the letter, P at 37. And if the rest of the context that that P was in got shifted before that got merged in, oh, my intention was to insert it at 37 and a P shows up there. But more likely, my intention was to insert the P after whatever letter came before it. And so we attach it to the letter and have some kind of coordinate system that survives that shifting around.
That's right. That's right.
And then, so there must be a piece of this that calls the shots when there's going to be a merge conflict.
Right.
How does that work?
Great question. So you got two options if there's a conflict, right? We both like inserting the letter P is never a conflict because you and I can both put the letter P after 37, or we can put two different letters. And we just have to pick what order to do it in.
Hmm.
It might not be useful, but it's not a conflict. But a conflict is, let's say we both set the title to something different. So there's two ways you can solve this. One is you can have what's called multi-values. And a multi-value is if you can have multiple values for any field. So in
Mhm.
this case, you'd get two titles, but then the programmer has to decide what to do with the two titles. And because this could happen anywhere, it makes it really hard to program because literally everything in your entire software could always be one or more values at any time. And that's totally insane to write
Mm.
code against. So what we do in Automerge is something much simpler, which is if there's two possible values, we just pick one. But we don't throw the other one away. What we do is we add it to a little list of conflict, which is to say that we have a little thing so that you as a developer, if you care, you can handle this. You can see, oh, there's a conflict. Oh, it's on this field. Okay, I'm going to put a little like star next to it. And if they click on it, I can see the different values and I can fix it. Most of the time, really kind of surprisingly to us, humans are pretty good at coordinating. And the kinds of edits, when you see something like this, they don't actually surprise or disturb people. If I made a to-do item that's like get mouth, and then you're like, oh, he typoed that and you just fix the I, and somebody else notices the same thing and fixes it, it doesn't matter which one we keep. There's also like, we're trained from these central data structures on this sort of last writer wins behavior. So like often if you and I are both editing the title of a to-do item or a Trello card or a GitHub issue or something, we both submit and mine loses. I'm not like, oh, those darn data system algorithm people have not built you're just like, oops, I guess somebody else fixed it. And
Right.
then you edit it again. You just redo the work. And so
Mhm.
where this becomes a problem though, is when the result of the conflict is separated by time and space from the creation of the conflict. And that's where you get into this sort of like version control situation where you want to be able to review what's happening. But in live kind of situation, if the work is less than 5 seconds of work, in sort of our anecdotal observation, people don't even view it as a conflict. They're just like, oops, and then they fix it. Like it
Right.
doesn't even, they're not conscious of anything weird happening because that's just what we expect computers to do. Where it becomes a bigger deal is if I spend a whole week offline working in a cave and like we have this saying in software, like no long running branches.
Right.
It's part of it because we don't have tools to do good integration when we have large change sets. So no long running branches. What constitutes a long running branch is really determined by how good the software that we use to manage change is.
So I guess something I'm curious about here is with something with like Automerge in particular, how much of this has to be baked into the data structure and I'm required to just get the merge, like if a conflict is occurring because the title got changed by two different people at the same time, do I kind of have to play by whatever rules Automerge work does, or is there some techniques for saying, oh, in my app I want conflicts to show
This
up
is a
like this?
common question, really good question. The result of resolving the conflict is arbitrary. And by arbitrary, I don't mean random. What I mean is consistent everywhere. And this is actually an extremely important property. So you can't take control of this. You can resolve the conflict differently by writing a new value and you can detect the conflict and do a thing. But it's really important that everybody everywhere sees the same value because let's say I'm running a newer version of the program that had a different, let's say we supported this. I'm running the new version that now uses a function to pick the different conflict. Oh, we'll choose the result from the person who has more seniority on the project. You're running the old version. Oh, we just pick the one that has the higher alphabetical sort. Now we don't see the same thing. So we've broken commutativity.
Hmm.
Now I make decisions based on what I see. You make decisions based on what you see. Even though we've exchanged data, we're no longer living in the same world. I could imagine someone being willing to make that trade, but I think it would make it so hard to write good software that I would strongly advise against it. And we have no intention of supporting it. If you care about like resolving conflicts, when you see a conflict, show both values, make a user take action or decide, or do something with that conflict result, you can do that. But don't fall into this trap of thinking like, oh, I need custom conflict resolution. Like
Gotcha.
that way is dangerous.
Right. So what I'm understanding you say is yes, there are tools for how to present this in a UI, but really the decision about how the conflict gets resolved and what counts as like the winner, which thing counts as the last winner needs to be more consistent than whatever the app says. But the app still will get a chance to figure out like how to guide you to your conflict resolution
Yeah, no
information.
matter
Yeah.
what, at least in Automerge, you have the full history of everything. You can always go back and look at one or the other. You can choose which thing you want to see. It's like having the full Git history. You don't have to pick one result. Nothing is ever lost. But it's very important, in my view, that everybody sees the same thing if they have the same data. That's what we promise with a CRDT is like, if you have the same data, you will see the same result because otherwise you'll make different decisions and then you get decoherence, right? You get divergence and then everything goes crazy.
Ah, this is all really fascinating. So, for maybe a final question before we start signing off, could you talk a little bit about what the lab is working on recently regarding auto emergency? Are there and CRDTs? Are there
Oh, yeah.
pieces of that tech that are the thing you're interested in pushing on now?
Last year, we published a paper called Upwelling, which was exploring collaboration around formal writing and kind of version control. The year before that, we published Paratext, which is rich text and CRDTs. We've been hard at work taking that kind of like researchware and making it real because we want to use it. Have supporters for Automerge who want to use it. We're going to ship that soon. I don't know if it'll be out by the time this podcast gets out, but certainly it's close. The other thing that we've done is like historically Automerge was like, it was a data structure. It was like a really fancy linked list. So it didn't plug in nicely to like an out of the box web development experience because you had to figure out like, oh, do I want to use WebSockets to copy these things around? Or how do I put this in IndexedDB and how do I load it from IndexedDB? So we have a new library called Automerge Repo that's coming out. Like it should be out by the time the podcast is out. I was like writing, it's out already. I was writing the launch blog post this morning, but it's awesome. It handles creating lots of documents and synchronizing them between clients and servers. It's got pluggable network and storage infrastructure. So you can stick stuff in Redis or you can use local storage, but out of the box, it comes with IndexedDB, node file system support, and synchronization over like browsers, broadcast, and message channels, but also over WebSocket between client and server. It's just going to make everybody's life so much easier. Our quick start guide has you up and running with a real app in 5 or 10 minutes and even shows you how it all works. So those docs are really cool. If you're listening to the podcast and want to check it out, it's automerge.org/docs/quickstart. Give it a try. Yeah, it's going to be really fun. I'm very excited about that. Beyond that, we think this like version control problem that we were talking about earlier is like really important and going to be very interesting. And so we're starting to dig in really now to this, like, how can we make it easy for everybody to build these little sort of lightweight mini version control systems into their apps? And then also, what does that look like? What does that feel like? How can we take, nobody wants to get the whole like complexity of Git in their chat app or their like
Hmm.
Google Doc, but we want a little bit of that. So how can we give developers the APIs that they need to build the parts that they want? And then also, how can we show them how simple it can be, how easy it can be to bring this stuff to their users, and how great it can be for users to have access to that kind of capability? Like, I want to be able to send everybody who's reviewing my like blog post draft in Google Doc a different version of the doc so that they can send suggestions without all colliding with each other in one big sort of brambly document. We can't do that today, but we think you should be able to, and we want to start exploring some of those kinds of questions. We've got lots of other stuff cooking. A lot of it is too early to really get into, but yeah, there's always more. Oh, and of course, we're always making it faster. There's tons of performance work always. It's hard to do anything. Like, the problem is every time Automerge gets faster, people bring us more data. And so it went from slower than the heat death of the universe to like sort an array to like, okay, but I want it on the next frame and I want to load all of Moby Dick. Okay. All right. We're going to do that. So we're working on that kind of stuff.
Awesome. Yeah, thanks for pointing us to where to go to check it out. So if I understand correctly, if someone wants to start building stuff with Automerge or probably Automerge repo, they can start doing that now.
That's right. Yeah. You go to automerge.org. There's links there. If you go to the quick start, it'll get you up and running. There's example apps that use React and Svelte, and plain old vanilla JS should be landed by then too. There's so much work to do, but there's a lot that's already done, and you can absolutely get up and running and start playing today. If all of this has piqued your interest, give it a try. We'd love to hear how it goes for you. You can hit me up on Mastodon on pvh@merveille.town. You can send me an email on pvh@incanswitch.com, or you can join the Automerge Slack and ask questions and tell us what you're up to.
All right, thank you.
Oh, thank you. This was really fun. It's nice to like really get into the guts a little bit and talk about how this stuff all works.
I learned a lot, so big thanks.